All right, question 9. Consider the following statements about a polynomial f(x). Again, same as the last question. All right, polynomial importance, okay, because it means continuity. All right. So let's look at the three options. Okay, let's actually read the question before looking at the options. I don't know why the options came before the question. Which of these statements is or is sufficient for the equation f(x) equals 0 to have a real solution? Okay, so at least one real root, I suppose. Right? Okay, so let's write this down. Continuous. Very important. So let's see. Option 1. So f(x) is a cubic where p is not 0, so it must be a cubic. Must it have a real root? I think so, right? Because cubics, it must pass through the x-axis somewhere, right? So 1 is sufficient, indeed, right? There's no way that you can draw a cubic without passing through the x-axis, right? Okay, 2. There's a real number t for which f prime t equals 0. That means that it has a maximum or a minimum. Is that sufficient? Oh, not really, right? Because you can just draw a quadratic, which has one max or min. You do something like this, right? Then it never crosses the x-axis. So no real roots, right? So 2 is not sufficient, right? I've drawn you something which doesn't satisfy the real root condition. So 2 is no good. Okay, how about 3? There are real numbers u and v for which fu fv is less than 0. Okay, what does this statement mean? Fu fv less than 0. That means that either f of u is positive and f of v is negative, or f of u is negative and f of v is positive, right? One is positive, one is negative. Okay, so is this sufficient for it to have a real root? Let's think about it. So I'm going to use the same graph as my quadratic. So let's call this u, let's call this v. Okay, so if f of u is negative and f of v is positive and polynomial continuous, okay, so then I must have something joining in between, and it must pass through, right? You can't avoid the x-intercept there, right? Okay, let's do the reverse then. I mean, the reverse is the same, right? If u was the positive guy and v was the negative guy, again, same thing. No matter what you do, okay, you can go up and go down, doesn't matter. You would hit the x-intercept somewhere, right? So there must be a real root, okay? I mean, it doesn't say that there's only one, right? It's at least one, right? Because you can have many if you somehow do dodgy things like this, right? Then you have 3, for example, right? So at least 1. So 3 is indeed sufficient, right? And that's where the continuity is important, right? Because if you're discontinuous, then again, you could just do something like up and then back up here, right? With asymptote in between or something. Then you have no x-intercept, right? So continuity, very important. This has a name, I think, also. What is this? This is the intermediate value theorem, I think. All right, so continuity, very important. Final answer, yes, no, yes, which is C.